So today we're going to cover Chapter 2, Section 3, and we're going to talk about using postulates and diagrams. Now, just to review, a postulate is determined from a definition or a rule. Now, all of these postulates on this page, we've already talked about. We didn't talk about them as postulates. We talked about them in Chapter 1 as definitions. Now, all of these postulates have names. They also have a number associated with it. All right, all of these have names associated with it and numbers. However, I don't want you to memorize the numbers. I want you to memorize either the name and then understand what the postulate says. So the first one is the 2-point postulate, and this just states that through any 2 points, there is exactly one line. I can't make more than one line when I graph 2 points. I could graph 2 points and then connect them, and I will graph and make exactly one line. The second postulate is called the line point postulate. And this one states that a line contains at least 2 points. So just like we learned in Chapter 1, in order to name a line, you need to name it with 2 points, unless there's a lowercase letter there. But you always need at least 2 points to form a line. Now you can have more, notice the word at least, you can have more than 2 points, but you need at least 2. And then postulate 3 states that if 2 lines intersect, then their intersection is exactly 1 point. So if I draw 2 lines here and show that they intersect, then I can see that their intersection is exactly 1 point. They don't overlap in more than one spot. Then postulate 4 is called the 3-point postulate, and this one states that through any 3 non-collinear points, there is exactly one plane. So again, remember to name a plane, you have to name it with 3 points that aren't all on the same line. So we could have 3 random points here, and they have to be non-collinear. Once I have those 3 non-collinear points, there is exactly one plane around them. Next slide, postulate number 5. Again, don't memorize the number, memorize the name. This one is called the plane point postulate, and this one states that a plane contains at least 3 non-collinear points. So again, you can have more points in your plane, but it has to have a minimum of 3. Okay, so it can be more, but you need at least. So it needs to be at least 3. Postulate number 6, or 2.6, and again, these numbers are just telling us that this is the 6th postulate in Chapter 2. Again, we don't want to know that number. So this one states, this one's called the plane line postulate, and this one states that if 2 points are in a plane, then the line that contains them is in the plane. So for example, if I have my 2 points here, and they're in a plane, then the line that contains those 2 points is also in the plane. And that's what the plane line postulate states. And then the last one is called the plane intersection postulate. And this one just states that 2 planes intersect. Then if 2 planes intersect, then their intersection is a line. And we talked about this as well. I think we even had a true-false question somewhere, either in the notes or in the warm-ups. So remember, planes go forever, so lines go forever. Remember, their intersection cannot be a line segment. It has to be a line. And actually, let me draw a better picture of a plane. So let's say I draw And when I talked about this in Chapter 1, I got out my piece of paper, I had cut it, And then I showed them how they fit together. And that could be the intersection of the two planes. So the intersection of my two planes would be a line. And then you can have the arrows on the end. Because remember, planes go forever, and so do lines. And that's postulate 2.7, but we're not memorizing that. You can memorize it as the plane intersection postulate. The next one is talking about perpendicular figures. Now, the symbol for perpendicular is an upside down T. So whenever you see a T that looks like it's upside down, that's an indicator for perpendicular lines. Now, in a figure or a diagram like this, the way that we could tell if two lines are perpendicular is perpendicular lines form right angles. So this one states a line is perpendicular to a plane if and only if, oh, we got a biconditional here, if and only if the line intersects the plane in a point and is perpendicular to every line in the plane that intersects it at that point. So notice line P there is intersecting line T, and it's forming a right angle. So that's how I can tell it's perpendicular. Same with line Q, intersecting point T, and it's also perpendicular because of the right angle. Doesn't matter where I draw the line, it's always going to be perpendicular to that line T. Now here it wants us to state the postulate illustrated by the diagram. Now, if you forget the name, just describe what you're seeing in the pictures. So for example, this is actually the line intersection postulate. So that's the name. So if you were to get this on a quiz, you could either tell me the name, but if you blank out and forget the name, describe what you see. So what I see here is if, and then now I have a picture of two lines. So if two lines intersect, so I have two intersecting lines in the first picture right here, then, and we got the word then, their intersection is exactly 1 point, which is what's in red. That's what the line intersection postulate states. Picture B, got a picture of two planes, and then after the word then, notice what's highlighted in red, and then this should be a clue that they're talking about the intersection, which is a line. So this is going to be the plane intersection postulate. And what that one states is if two planes intersect, then their intersection is a line. So know what the postulates say. You don't need to have it word for word, but it's got to have the right meaning. Or memorize the names. Either way, for the quiz on Tuesday. So here's example 2. It says use the diagram to write examples of the plane point postulate and the plane line postulate. So let me go ahead and do the plane point first. So the plane point postulate states that a plane contains at least 3 non-collinear points. So in the picture, you could say plane P contains at least 3 non-collinear points, and you can say that those points are A, B, and C that are in plane P. The plane line postulate, this one states that if 2 points are in a plane, then the line that contains them is also in the plane. So based on the picture, I could say point A and point B lie in plane P. So line N, and you could also call it line AB, containing points A and B, also lies in plane P. So if the 2 points are in the plane, so is the line that contains those points. It will also be in the plane. This one wants us to figure out which one of these statements cannot be assumed from the diagram. So let's go ahead and take a look. Can we assume that A, B, and F are collinear? Let's see where they are. And yes, we can. Here's A, B, and F, and they're all connected by this line. So this one's good. Yes, we can assume that. However, notice E, B, and D, they're right here. They sure look like they're on a straight line. They look like they're collinear, but there's nothing connecting them. So we cannot assume that A, B, or E, B, and D are collinear. There's no connection between them. Remember that upside down T is the symbol for perpendicular. So here it wants us to check to see if AB is perpendicular to plane S. Remember, the thing that we're looking for is that right angle. So here is AB, and here is plane S. At that point is where it intersects. It's got the little right angle. So yes, we can assume that because of that right angle indicating that it's perpendicular. However, when we take a look at CD and see if it's perpendicular to plane T, notice what's missing is the perpendicular indicator showing that that could be perpendicular. So without that right angle, I cannot assume that CD is perpendicular to T. And then the last one, AF intersects BC at point B. And yes, we can assume that because here's the point of intersection. So that one's good. So the main thing to look for perpendicular is always look for a right angle marking. All right, last one. We're just going to identify some supplementary angles and vertical angles. And again, back from chapter 1, this is where we learned about vertical and supplementary. So let's see if we can name some. Now, as far as the supplementary angles, there's a bunch. So let's name the vertical ones first. So the vertical angles, I've got 2 pairs. My first vertical pair could be PWV along with TWQ. These are vertical angles. Remember I showed you with the V and maybe make it look like an A. So you can either list this in this order. The W has to be in the middle. So PWV along with angle TWQ. You could also reverse it. Just make sure the W stays in the middle. So you could also call it QWT. Now we also have another pair that goes sideways. So this one is also vertical to this one. So the other pair, you could also have named as angle PWT along with angle VWQ, or reverse the order of the letters, TWP and angle QWV. Any combination there. Again, you can reverse it. Just make sure W stays in the middle. Those are all the verticals. Now let's go look for the supplements. Erase all this. So now for the supplementary angles, we've got a pair, and again, they're going to form a line. They'll be sitting on a line. So we have PWV along with VWQ. This is a pair of supplements. So let me go ahead and list that. So I can say PWV along with angle VWQ. That's one pair. Let me erase the red. And I could keep rotating around. Now, I could have also still used the PWV, and then I could list the other supplement this way. So I could still state that PWV, and this time it's with angle TWP. Remember, on all these, you can reverse the letters as well. I can keep going around my figure. So now I could go from this one to this one. So there's a whole bunch here. So this one would be PWT and VWQ. And I can keep going all the way around. So there's a whole bunch of supplements here. Just realize that these two sides, they're going to form a straight line. Everybody good? There's more, but that's a good start. All right, so that is it for the notes on 2.3. So again, it was a lot of review of chapter 1 all over again, but now officially presenting them as postulates. So you do have a homework assignment that is due on Monday. Now, when you come in on Monday, do the warm-up for 2.1 that we missed because it wasn't posted, and then the 2.3. We'll go over homework, we'll go over the warm-ups, and then we'll start reviewing for the quiz. And that is it for 2.3.